Hello guys, so welcome back to our course. In this video, we're gonna cover two important concepts. The first one is timing diagram, and the second one is basically circuit concept or basic circuit drawings. So let's start by the timing diagrams. So basically, a timing diagram is a way to show how the output will vary with the input, with a continuous input, basically. So remember that this is a circuit. Whatever you have here, that's like an AND gate. It's, at the end, it's a circuit. This AND gate is just some transistors connected to each other, okay? And remember again that the 1 and the 0 is the concept of 1 and 0 is basically voltages. 0 is just a symbol for low voltage. It can be 0, it can be -1, it can be even 1, whatever, And 1 is a symbol for high voltage. It can be 5, it can be, 10. So basically it is two voltages, low and high, and there is, a difference between them, considerable one. And the voltages basically came from some source, like a battery. And the battery, it will give you continuous volt. So what will be the output in these cases? If you have a continuous input, what will be the shape of the output? This is basically how to do a timing diagram, okay? So let's take an example. This example is already solved. So you have here an AND gate, and you have two inputs, of course, A and B, and the output is Y. So let's follow, the definition of AND gate and see how we can draw or redraw, because it's already drawn, the output Y, okay? So here is the shape, basically, of A. Here is the shape of the signal B. So we have here two signals, A and B. And you want to construct or draw the output. What would be the output Y? The shape of the output Y. Okay. You can take or you can divide, the input A and B based on the variations. Remember that A and B can take only two values, zeros and ones. Okay. So you can just come at the transitioning points and draw, like separators like this, which I draw in green here. Then do the calculations based on each division. So you have here one division, the second division, third, and the fourth. Let's start by the first one. So during the first division here, A is 0 all the time. B is also 0 all the time. Okay, so the output Y will be 0 as well. And you can do that point by point, although you have here infinite points, but you can just take samples, like here at that particular time, A is 0, at the same time B is 0, so at the same time Y will be 0. At that time, for example, time instance, A is 0, B is 0, so Y will be 0. So you can just, tabulate any point here in Y with 0. Or you can just draw a line, because all the values of A and B are 0, so you're going to have 0 all the time. Let's do the second division, in which A all the time is 1, B all the time is 0. This is an AND gate. So 0 ended with anything will be 0. So we're going to have 0 all the time in y in the division, the second division. And you can do point by point. So for example, at that point here, a is 1. At the same time, b is 0. So y will be 0. Another point, a is still 1. b 0. So y will be 0. And that will happen at any point, in the second division. Third division. Now a is 0 and b is 1. Still same concept because this is an AND gate. So basically you're going to have also 0. Finally, in the fourth division, a is 1, b is 1. Since this is an AND gate, so y will be 1. At that instant of time, y changes or change it from 0 to 1. So basically, you connect them like this. Remember, this is a circuit. So if you have an oscilloscope, a CRO device that inspect or show, display to use the shape of a signal, it will be a continuous function. That's the first example. Let's have another example, which now it's OR gate. And you want to know the divisions A, B, and C. So there are other divisions like this division and that division. The output Y is known. Okay, for the A division, this part here, the input J is 1. The input K is 0. So 1 or 0 will give you 1. So we're going to have 1 here. You can check by taking simple points in between, like this point is 1, the corresponding point is 0, and 1 or 0 is 1, and the corresponding it's 1 here. So we're good. In the B division, you have 1 in J, you have 1 in K, so you're gonna have 1 in Y. In the C division, you have 0 in J, 0 in K, and the 0 or 0 will give you 0. Remember, this is a continuous function. So between the first division and the A division, the first and the second, basically, there is a change from 0 to 1. So you must connect these together. From the fourth division, this is the fourth. And the fifth, which is C, there is another change from 1 to 0. Again, this is a continuous function, so we change continuously like this. Okay, guys, that's basically the timing diagram with very two simple examples. Let's now explore the circuit conventions. How basically to draw a circuit, a correct circuit, okay, in our course. First, the intersections. Okay, if you have two wires on top of each other, when I consider them connected and when I consider them not connected. So we use this convention that to connect two wires, we draw a bullet point on two. So if you have two two pieces like AB and CD, two wires like this, okay? In that case, they are not connected, not connected. It's branched. To connect them, we put bullet point like this on the intersection. So with the bullet point, they become connected. So only if we draw the bullet point, we connect the two wires. Like in here, C, wire C, this wire here, let's draw back with red. So this wire here, C, is intersecting with B. But since there is no bullet point, then they are not connected. But it's connected to that one. So this one, this input basically for the second AND gate, and this one for the first AND gate, they are connected. They are the same point C, or same input C. When you have an inverter at an input for any gate, like an AND gate, for example, here, we usually draw just this inverter as a circle, small circuit at the input, like this. So we convert this inverter into that small circuit. Although they are both correct. If you wanna keep the inverter, keep it, no problem at all. The third concept is basically branching. So you have two cases here. One is bad case, not okay at all, and an okay case. So let's start by the okay case. If you have an output, certain output, this output can be branched, can go to, for example, two other gates. Like, for example, in that case here, you have the output, let's call it Y, and this Y has been branched to two other circuits or piece of circuits. Like, for example, an AND gate here with an input called A, and for example, an OR gate with an input called, let's call it C. That's no problem at all. But the problem is here. That's wrong. That you have input came from two sources. So an output can be branched, an input cannot. You cannot have two sources. Because basically, if you draw, let's analyze this. So you are saying that you have same wire, same input coming from two sources, A and B. But remember, A and B are a source of a voltage, either low or high. If it's a high, that means it's connected to the VCC, a battery. If it's low, that means, for example, it's zero, connected to ground. So if you draw, in that case, if A and B are the same, I mean high or low, both are high or both are low, that's no problem. But if they are different, I mean, for example, A is high, which means A is connected to a battery like this, and B is low, which means it's connected to ground, then you have a short. So you have here a current flowing from the battery to the ground directly. Of course, there will be no current here. Y is equal to 0 in that branch. Why? Because you have a short. If you have a short parallel with whatever, So the current will always go to the short circuit. It will not go here. And this current here, let's call it I1, is equal to infinity, which is really bad. You have a short circuit. That's why that's not okay at all. So an output can be branched, an input cannot. Another, conventions that we're gonna see a lot in this course is that when you have one input connected to multiple gates, so to avoid having intersections, and confusion, we draw it twice. So we convert this into this. So here you have the input A, same input A, is going to two AND gates. So instead of having this branch, we just draw A 2 times, which is correct. But in your mind, they are the same. Of course, they are the same. Both are A. Finally, and this is something maybe you will not encounter, is that we don't label any gate input from inside the gate. But maybe for a block diagram, you can do that. Like here, you have a block. I mean, this block means inside here, there is a circuit with multiple gates. Yeah, this one the inputs can be labeled from inside. But one gate, like an AND gate or OR gate, or NAND or not, we don't label from inside. Okay, guys, that was it for the timing diagram and the circuit conventions. So this is basically lecture 1. And, next week, we're going to publish more lectures on that course. Thank you very much for watching and see you in next week. Bye-bye.